the most powerful stellar explosion that transformed our universe forever. In October 2022, a stellar explosion so bright and powerful that it blinded gamma-ray detectors worldwide broke all known records. It emitted more energy in seconds than our Sunday in its entire lifetime. This is the story of that cosmic event, nicknamed the Brightest of All Time, and how it changed our understanding of the universe. Welcome to Mind-Blown Space, where today we will unveil the secrets of this colossal explosion, the burst that blinded the cosmos. Imagine a flash surpassing anything humanity has ever witnessed. That happened in October 2022, when a stellar explosion known as a gamma ray burst across the cosmos. Detectors around the planet were temporarily blinded by its intensity. How can a phenomenon release more energy in seconds than our Sunday in 9 billion years? That is the question that puzzled scientists and astronomers for months. This explosion was so close, only 2 billion light-years away, that it became the most studied gamma-ray burst in history. Despite that, it had strange characteristics. It lacked some typical signals these events usually show, leading to doubts about several aspects of our universe's standard model. Furthermore, it opened the door to the possibility of new particles, like the hypothetical axion, which could be the key to understanding dark matter. Gamma-ray bursts are intense, brief flashes of radiation that can last from milliseconds to minutes. The first detected was in 1967, thanks to American satellites monitoring secret Soviet nuclear tests. Since then, these phenomena have been a window to the most extreme and exotic processes of the cosmos. There are two main types: short bursts, lasting less than 2 seconds, attributed to collisions of neutron stars or with black holes, and long bursts, lasting more than 2 seconds, produced by the explosion of giant stars. Our protagonist, the brightest of all time, was a long burst, a reflection of the collapse of a giant star that ended in a black hole. But what made this burst so special? Its duration of 10 minutes, its persistent brightness for hours, and its relative closeness, something almost unique in our observation history. Could it be a phenomenon that repeats every 10,000 years? Just imagine, the last time it happened, humans were barely starting to farm the land. The explosion and its hidden secrets. Although the initial explanation for the brightest burst of all time was the death of a gigantic star, the details soon became more confusing. The supernova accompanying this event, which should have been extraordinarily bright, turned out to be quite ordinary and without exceptional features. This revelation puzzled astronomers, as it did not fit with the enormous energy released in gamma rays. To delve deeper into the mystery, scientists aimed the powerful James Webb Telescope at the source of the explosion. What they discovered was an average supernova, lacking the expected intensity that would justify such a cosmic burst. This disconnect between the normal supernova and the anomalous burst raised new questions. How could such an ordinary explosion generate such extraordinary radiation? One possible explanation lies in Earth's relative position to the burst. Imagine a flashlight emitting diffused light, softly illuminating a small space in front of you. Now imagine all that light concentrated into a narrow, powerful laser beam. If you are directly in the path of that laser, you would see an extremely intense light, much brighter than the original flashlight, even though the energy source hasn't changed. Similarly, if the gamma-ray burst particle jet was perfectly aligned with Earth, it would appear much brighter than usual. Moreover, this burst showed particle jets much narrower and faster than any previously recorded, reaching speeds close to light and traveling for 2 billion years until reaching here, where they even caused a momentary disturbance in our ionosphere, that layer rich in electric particles surrounding our planet. This interaction was so intense it pushed the ionosphere to lower altitudes, comparable to the effect of a major solar storm. Data collected by the Large High-Altitude Air Shower Observatory in China revealed an unprecedented amount of high-energy photons from this explosion, surpassing any previous record in gamma-ray astronomy. This data even suggests that something may be missing in our current models of the universe, opening the door to new theories in physics and cosmology. The enigma of dark matter and the creation of heavy elements. Among the most intriguing hypotheses to explain the enormous energy of this burst is the possible existence of particles called Axions, which could transform photons into invisible particles during their 2 billion-year journey across the cosmos and then reconvert them into gamma rays upon reaching our galaxy, thanks to its magnetic field. These Axions are candidates for the famous dark matter, a mystery that still baffles scientists because it cannot be detected by traditional methods and lies outside the standard model of physics. Returning to the explosion, or collapsar, as they call the explosive death of a massive star that results in a black hole. It is known that these events not only release gamma rays but are also responsible for the creation of heavy elements, such as gold and platinum, through complex nuclear processes. This occurs because the star's core, under extreme pressures and temperatures, generates nuclear fusions that build heavier elements from lighter ones. However, the amount of gold in the universe cannot be explained solely by these supernovae. It is believed that collisions between neutron stars also play a fundamental role by emitting enormous amounts of neutrons that, as they decay radioactively, form heavy elements. This process, called rapid nucleosynthesis, is responsible for the creation of much of the periodic table's elements beyond iron. Curiously, the analysis of the spectrum of the brightest burst showed no clear signs of these heavy elements, which raises questions about whether these explosions are really the only source of precious metals in the cosmos. Some scientists suggest that the environment where the burst occurred, a galaxy with very low metallicity, may have limited the formation of these elements. This discovery invites us to rethink our models on how elements are formed in the universe, even questioning the validity of certain theories about stellar evolution and galactic formation. The mystery is open, and every new data point can radically change our understanding of the cosmos and its fundamental processes. This cosmic burst, the brightest ever recorded, has revealed to us that the universe is a much more complex and enigmatic place than we imagined. From the interaction of unknown particles to the processes that create the elements that form everything we know, each discovery opens new questions and paths to explore. The explosion that compressed our atmosphere from 2 billion light-years away reminds us that we are part of a dynamic cosmos, constantly changing and evolving. Supersonic storms and winds, chaos on the coldest planet. If you thought Neptune was just a huge, cold blue dot lost in space, get ready to discover that it is actually a giant hurricane with an atmospheric fury that would make any earthly storm seem like a summer breeze. Neptune has recorded the fastest winds in the solar system, reaching incredible speeds of up to 2,160 kilometers per hour, almost twice the speed of sound on Earth. These winds blow in a retrograde direction in the planet's atmosphere, meaning opposite to its rotation. Imagine a tornado so large it could swallow an entire continent and with a force capable of destroying everything in its path, but multiplied by thousands. In 1989, the Voyager 2 probe observed on Neptune a giant storm called the Great Dark Spot, comparable in size to the entire Earth. However, unlike Jupiter's Great Red Spot, these storms on Neptune seem to appear and disappear within years, never permanent. In fact, when the Hubble telescope tried to find the Great Dark Spot in 1999, it had already vanished, as if the planet's nature were too unpredictable even for us. But why this atmospheric madness on such a distant and cold planet? The answer seems related to the internal heat we mentioned earlier. Although Neptune is billions of kilometers from the Sun, its interior generates enough energy to fuel these titanic storms. That energy causes methane and other gases to flow, creating a dynamic and violent atmospheric system, with cloud bands forming whirlpools and giant waves. Furthermore, atmospheric pressure and chemical composition make these storms unique, with bright clouds of frozen methane crystals rising to great heights. It's not just wind and gas, but a climatic ballet that defies understanding, with a terrifying beauty. Neptune is not the calm and cold planet we imagined. It is cosmic chaos disguised in blue, a reminder that even in the farthest corners of the solar system, fury can reign fiercely. If you are fascinated by this journey through the mysteries of the universe, you cannot miss our video, The Entire Evolution of the Earth in Just 10 Minutes, where we explore how our planet has changed from its origins to today, condensing billions of years into a fast and surprising narrative. Don't forget to subscribe to Espacio Flipante to keep discovering the most incredible secrets of the cosmos. Activate the notification bell so you don't miss any video, and leave us a comment about which space mystery you want us to tackle on the next adventure. See you on the next trip through space.